All right, welcome back. So this should be the last section for question number 12, page 25. Now we are dealing with an exponential function. P of x is equal to 2 to the power of x. So let's see what that looks like as a graph. And this is an exponential function. Starts off small and then grows rapidly. What is the domain for this function? Well, does this function go all the way to the left? Yes, it does. Does this function go all the way to the right? Yes, it does. So in this case, it's just xer. What about the range? Does this function go all the way up? Yes, it does. Does this function all the way down? No, it does not. At what point does it stop going down? You can clearly see that it's around 0. Now the question is, does it include 0 in your range? And in this case, you do not, because there's a horizontal asymptote. So y can never actually be 0. They can get very close to 0. So the range is y is greater than 0. As for intervals of increase, this function is always increasing. You can clearly see as you move to the right, it's going up, 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 up. So intervals of increase is from negative infinity to positive infinity. Intervals of decrease, there are none. Discontinuities, none, but there are asymptotes. So I guess we can just write the asymptote. And there's a horizontal asymptote at y equals 0. As for the x-intercepts, this function doesn't intersect the x-axis, so none. Y-intercepts, 0, 1, because it intersects the y-axis at 1. Symmetry. Okay, let's see. Let's see what's happening with symmetry. If I sub in a negative x value into this equation, to the power of negative x, and if I simplify that, that's just 1 over to the power of x. Remember, a negative exponent means you kind of flip the fraction. Now, does this look exactly like the original function? It is not. And is it the same as taking negative 1 and multiplying it? Something like that. And no, it's not. So it's not odd, it's not even, so it's neither. And end behaviors, pretty straightforward. When x goes to positive infinity, when x gets bigger and bigger, what's happening with y? Well, y is getting bigger and bigger as well. And when x is getting smaller and smaller, what's happening with y? Y is actually approaching 0. So that's interesting. All right. And now our final parent function. Sine x. So this is what sine x looks like, if you guys remember. And usually for the x-axis, we usually use degrees in grade 11, but now in grade 12, you will be learning something called radians later on. But let's sketch it. Domain. The domain is x belongs to all the real numbers, because this function goes all the way to the left and all the way to the right. What about y? Does this function go all the way to the top? And no, it doesn't. It has a maximum value of 1. What about all the way to the bottom? It does not. It has a minimum value of negative 1. So that means that your y values have to be between these two, maximum and minimum. So between negative 1 and 1, and it's including negative 1 and 1. So there's an equal sign. Intervals of increase. So this is interesting here because your increasing intervals are from kind of like the minimum point to the maximum point. And then you kind of skip this middle point here when it's going down, but then you have another interval of increase from the minimum point to the maximum point. And it repeats forever. So that is a little bit difficult, but I'm gonna tell you exactly how to write that down. So 90 bracket 4k plus 1. comma 90 bracket 4k plus 3. And k belongs to z, which is integers. So k can only be values that are like, 1, 2, 3, 4, 5, 6, and negative values because it's an integer. And this is a little bit more difficult. So we will elaborate a little bit more later on. Similarly, your intervals of decrease are from 90 bracket 4k plus 1. Sorry, I'm just copying that. Sorry, I just looked there. Just copying the same thing up top. No, it's the other way around. K plus 3, comma 2, 90 bracket 4k plus 1. Same thing, k belongs to all the integer values. So from this point to this point, this point to this point, these are all your intervals of increase and decrease. Are there any discontinuities or asymptotes? Nope, there are none. Zeros, what are the zeros? Well, zeros are always occurring at 0, and remember if we're doing degrees, 180, then 0, 90, 180, 270, 360, 0, 180, 360, and so on. So there are intervals of 180 degrees. So we're just going to write 180 k, and then where k belongs to integer values. So any value for k that's an integer, you can have a 0. So when k is 0, 0. When k is 1, 180. When k is 2, 360. When k is 3, it's 3 times 180. 6, 40, 54, 540, and so on. Oh, I didn't actually show you, but here, if I plugged in the value of k equals 1, if I plugged in 1 in here, so that's going to be 4 times 1, so 4 plus 1 is 5. What's 90 times 5? That's going to be something like 90 times 5 is 450, right? So from 452, and in this case, it would be 1 again, so 4 times 1, 4, plus 7, 90 times 7, that's going to be 630. So from 450 degrees to 630 degrees would be an interval in where it would be in intervals of increase. Let's see if my values were. Let's put a 0 value for k. K was 0. So this would be 4 times 0 is 0, plus 1 is 1. So 90 times 1, so that would be between 90 and, once again, if I put 0 here, that would be 90 times 3, 270. So between 90 and 270, there should be an interval of increase. Let's see, is that true? So 90 is here, 270 is here, and that is an interval of decrease. Did I do it backwards? Possibly. I'll have to look into that. But yeah, okay, so y-intercepts. So y-intercepts are 0, 0, that's easy. Symmetry. Symmetry in this case, it's pretty straightforward actually, you can do this. I'll look into the intervals of increase and decrease to see if I can explain it a little bit better. As for the symmetry, remember we sub in negative x into the equation. And if you remember from grade 11, I'm not sure if you were told this, but you can actually take out that negative value here, and that is equivalent. So sine of negative x is equal to, you can take that negative sign out, and you can only do that for sine x. Don't do this for cos, because sine is an odd function. So this has odd symmetry. And in terms of end behaviors, well, this doesn't really have any end behaviors because it's always oscillating. It's just going up and down, up and down, up and down. So yeah, so that's how we write that. Okay, that's it about sine x. Hopefully that was useful. Take care.